Okay, so next up we have Kuassi Mensah and Michael McMahon from Oracle, and they will be sharing the story of the making of the Oracle R2DBC driver. So I'm going to hand it over to Kuassi and Michael.
Thank you. Hello, everybody. Welcome to this session. My name is Kuassi Mensah. I do product management for everything Java for the Oracle database. And with me is Michael. Michael, introduce yourself.
Hi, I'm Michael. I program the R2DBC driver and the JDBC driver for Oracle.
Excellent. So let me move to the next slide. Okay, this is the agenda. We will tell you how we get here, where we're coming from, and how we get here. And then we'll talk about the making of the Oracle R2DBC driver, and then taking your code from Synchronous to Reactive. So once upon a time, long time ago, 2017, that's a long time, the JDBC development started this asynchronous database access API project. And so some of you might have heard about ADBA, and that's what it is. So our goal was to come up with a standard Java API for database access that never blocks user threads. Very important. And the second goal was it is not a complement or it is not compatible with JDBC. It's a totally new, different API, right? And the motivation or use cases where asynchronous applications have better throughput. That was our belief, but some people think different, and we'll see in the next slide. And then simultaneous access to multiple databases. So you can do a map reduce to accessing multiple database nodes, sharded databases where you can access multiple shards from the same application without waiting for connection or statements to come back to you. And then fire and forget. So you want to issue some DML or invoke a stored proc and not wait for the return. So that's what we're calling fire and forget. So it was a beautiful and sophisticated API. And you can see the API at the location at the bottom of the slide. So the question you might ask is, oh, why, if this is so beautiful and sophisticated, why did you stop it? So why did we stop working on ADBA? So there are two main reasons. The first one is the Sun/Oracle Java SE team. That's the team that defines what goes into Java SE. They build the JDK, they define what the APIs of Java SE is, and they strongly believe that the future of Java scalability is virtual thread. They are the people behind the virtual thread, the project Loom. So they believe that ADBA will not be accepted as a standard by them, and because they control a little bit the standard, not just them, but the GCP, but they believe it won't be accepted because it was an asynchronous solution to a problem that could be solved by virtual thread. That's why I was saying some people believe that we don't need to do asynchronous programming. So that's a strong belief. And the problem for us is until it becomes a standard, it's not worth our effort, right? It's not worth so how would people adopt something if it's not a standard? So the other thing we could have done is turn this into an open source, but we are good corporate citizens. We cannot go rogue and go do something that's the people who control Java SE don't believe that we should be doing that. So anyway, you understand what I'm trying to say. The second reason is you, the Java community. So you guys did not express strong support for this API. And we believe that you were already gravitating towards R2DBC. Okay, so that's why we stopped. Then what? Well, we changed our focus on three things. The first one is everything we've learned from doing ADBA, we took some stuff from that and we came up with a reactive extension in the Oracle JDBC driver. It's not a standard API, it's just an extension, a proprietary extension to the Oracle JDBC driver. And then we started working on the Oracle R2DBC driver, and Michael will talk to you about all those things in a moment. And we also started instrumenting our driver to support the virtual thread. Remember, the Java SE told us virtual threads are the future of Java scalability. So anyway, as we speak, the JDBC driver supports virtual threads, so you can play with it. The API itself is not standard, but you can play with it. And here is a summary of the reactive extension. And those who are familiar with JDBC, you can see the parallel with JDBC. So we need to get a connection. So we got a connection builder. And by the way, this reactive extension implements the Java util concurrent flow. So it implements the publisher and the subscriber interfaces. That's why you will see that we are returning publisher for most of the prepare statement execution, et cetera, et cetera. So what you're seeing here is that each call is similar to JDBC call, but with async Oracle as postfix. Async for sure. Also, we added Oracle in case the Java community likes it and decided to make it a standard. In that case, there won't be no clash. So they can say execute async, and there will be no clash with our extension. So anyway, until then, this is what we got. So it's similar to JDBC execute. Okay, so it returns a Boolean, true or false, returns a long, the count, et cetera, et cetera. So you can see the parallel with all the JDBC calls, execute, query, async, return to publisher. And this is how you get the result set. So we got a publisher Oracle with a function which will map the row to a type. And then we have the function for log processing, log reading, log writing, et cetera, et cetera. And then we have the commit, the closing, the connection, et cetera, et cetera. Michael will zoom a little bit into that later on. To finish up my intro, this is a summary of what you can do today with the Oracle JDBC driver. So read from the bottom to the top. You can do synchronous call using the standard JDBC API. That's what the driver has traditionally been made for, right? Synchronous blocking calls. Then with the reactive extension, remember it implements Java SE flow. So we support non-blocking with back pressure. And it's built into the driver. That's the dotted red line around surrounding. Right, so you could use it, you could do a synchronous call with non-blocking back pressure using the API I just showed you in the previous slide. Now, if you add third-party reactive streams libraries such as Reactor, RX Java, Akka Streams, Vertex, et cetera, you get more functionalities. You get operators, you get concurrency modeling, you get monitoring, you get tracing, you get everything that you don't have in Java SE, right? You don't have those things as part of Java, as part of Flow, right? And we know that people have been using our extension with some third-party library to release a product. I'm not gonna name names here, but people are using it. So with this, you have a full reactive streams. Right, so that's a summary of what we can do today. And Michael will add another summary at the end, but this is what we have. And I'm gonna turn to Michael and I'm gonna stop sharing. Michael, please go ahead and share your screen.
Okay. Let's bring this up.
At the bottom, the green button.
Thank you. Okay. So I was the programmer who was tasked with actually implementing these reactive extensions for JDBC. And the whole objective of that project really is to say, let's start with something like what we have on the left side of my screen here. Let's start with a blocking implementation of a statement execute. And let's essentially translate that into an asynchronous, non-blocking, reactive method that has the exact same functionality, except it won't block your thread. So if you know JDBC and you know what a statement execute method does, you're going to instantly know, okay, I now know what execute async does. It will, as the exact same behavior. I just need to think about how am I going to deal with the asynchronous model, where instead of the method returning a result, it's going to return a publisher, and I can attach a callback to that and receive the result asynchronously. So what we end up with on the right is this method that we'll explain what's going on here on both sides. So we enter a method. We need to check, is our statement closed? If it is, we got to throw a SQL exception at you. Do some more checks. Look at our bind values. Make sure those are all set. If everything's all set, now we're going to clean up the state from any previous execution, because you can execute a statement multiple times. So if we have a result set hanging around, we'll close that and we'll reset the update count. And we do the exact same thing for both implementations. And then we make our actual database call. So here on the left side, we call execute SQL on our connection object. And this will do a blocking database call. This will go down to the network layer, where we have something like a socket channel. And it will write a request over the network to the database saying the request is basically go execute the SQL. And then it would do a blocking socket read and wait for a response from the database. And the response is going to be the result of executing that SQL. So that's the part where we go in a different direction now. On the right side, for async, we would call a newly added asynchronous kind of translation of that execute SQL method. And that asynchronous translation is going to return a publisher type. So in the synchronous code on the left, the execute SQL method returns a SQL result object. And in the asynchronous code on the right, it would return a publisher that would emit a SQL result object. That's sort of the asynchronous way of returning a value, is emitting it from a publisher. And once we have a SQL result object, we can go into where I left the comment, handle the result. And now we update the state of our JDBC statement with the new result set. If there is one, it might be null. Or the update count if the SQL resulted in an update count, like an insert or update or delete statement. And finally, we get our return value, which is a Boolean. And it just indicates whether or not the SQL resulted in row data. So if we see a non-null result set, we'll return true. And that tells the user code, or whatever code is calling this, it might be Spring, this SQL execution has resulted in row data, and you can now call get result set and go iterate over that result set. We do the same thing with the asynchronous version, except now we're going to use a callback. So we see this flux type. That's from Project Reactor, which Kuassi spoke about earlier. Flux is an implementation of publisher, and it lets us work with a reactive stream much like Java util stream, where you can take a collection and you can turn it into a stream, and you can apply a sequence of operations to that stream of values. We can do the same thing with an asynchronous reactive stream. So to handle the result of the asynchronous execution, we apply a map operation. And this is going to do exactly what the synchronous code does. It updates the statement, and it evaluates whether or not the result set is null to create a Boolean. And so this has the publisher return by execute async Oracle emit a Boolean value. So one thing we can notice about these two implementations is there's a lot of common code. And I've highlighted in the blue and green boxes, this is the exact same code. And this is what we would expect, because for the reactive extensions, we want to replicate the behavior of the synchronous method. So we end up having the exact same code, and we can kind of pick out different sections here. So our blue section is everything we need to do before our database call. And the green section is everything we do after the call completes. And then the only difference between the two is which method do we call to actually do this network IO with the database? And the reactive extensions will use the asynchronous version. So now at this point, if we just stopped here, this wouldn't be so good, because now we have a lot of duplicate code, and that can be a major drag. So, if someone comes into the execute method and they need to work on it or add something or fix something, now they have to make that same change in two places, which would be horrible. So what we end up doing is we refactor the existing synchronous methods, and we pull out the block of code that goes before the database call, move that into a separate method, and we'll call that prepare for execute. And we move all the code that runs after the database call, that goes into a separate method, which is the result handling handle result method. And then we end up with our execute and execute async Oracle methods looking like how they do above, where now they're very small, and it's very easy to see these are doing the same thing. And if we need to change the behavior, we can just change it in one place. We can just change it in the prepare method or the handling method. Another nice thing about this is when we move stuff into smaller methods, it's a little easier to read the code. So one thing that makes it easier is if we're looking at these execute methods on the top, there's not so much clutter, right? Like we can kind of get a high level understanding of what does this method do? Okay, it prepares the state of the statement to get ready for an execution. It executes the call, and then it handles the result. So now I can just see that, and I can move on quickly. Or if I need more details, okay, what exactly do we do to prepare? Or what exactly do we do when we handle the result? I can now kind of drill down into the individual methods and understand that. So this kind of translation and this refactoring of all the synchronous methods, this happens all the way down the stack, right? Because we couldn't just refactor statement execute and then add statement execute async Oracle and then be done. Because statement execute now calls into another blocking method, which we saw as the execute SQL method on the JDBC connection. So now we have to go to the execute SQL method and go and do that refactoring as well. And again, we're kind of picking out the setup code and the result handling code, refactoring that into separate methods, and then sharing that code with the new async method. And so we go all the way down the stack with that, with synchronous, until we get to that blocking socket channel call. Now for the reactive JDBC, we're going to do non-blocking IO. So we're not going to do a blocking socket read. And instead, we use a selector, which, if you don't know selector, it's a way to do what we call multiplexing. So if I have 1,000 database connections, I have 1,000 socket channels, each one representing a network channel to the database. I can register all of those with one selector object. And now I can have one thread just pulling this one selector object and essentially handling the socket read for 1,000 different channels. And you can do more than 1,000. I'm just using that number as an example. So what the non-blocking code does is it registers the socket channel with a selector, and it attaches a callback to that registration. So once the selector sees the channel is ready for a read event, this tells us, okay, the database has come back with a response. And at that point, we can invoke the callback. The callback is essentially a big chain of those green result handling functions. And those execute and kind of bring us all the way back up the stack until we get back to that publisher we saw, and its map function is called. And it evaluates the result set and creates a Boolean, and that is the result that the publisher emits back to whatever code is calling the reactive extensions. Okay, so now that we have these reactive extensions APIs, we kind of have the foundation to create an R2DBC driver. And this is what we did. This is the Oracle R2DBC project. It's on GitHub. I put a link below. Because while the two APIs, the reactive extensions and R2DBC, are definitely not totally identical, we can still adapt them. We can adapt the reactive extensions in a way that they will behave according to the specification of R2DBC. So some things we might adapt is, rather than having a JDK flow publisher, which was only added in JDK 9, we can adapt that into an org.reactiveStreams publisher type. That's a type defined by the Reactive Streams JVM project. It's also on GitHub. And it's JDK 8 compatible, which is the nice thing about that type. But other than that, it's completely identical to the JDK flow publisher type. It's the same name, same method names, same specification. Another example of a adaptation we might make from reactive extensions to R2DBC is something like a SQL exception. That's the exception type a JDBC driver will throw. It's a checked exception, which is not so great if you're doing functional programming, because most functional types, the method signature does not allow it to throw a checked exception. So we can translate a SQL exception to an R2DBC exception, which is an unchecked type, and essentially offers the same functionality as a SQL exception, where you can get like an error code or a SQL state. Another thing we'll adapt is using more modern type mappings. So JDBC was designed in a very, very early release of Java. I think it might have been Java 1.2. I wasn't around for that. But at the time, if your problem was what kind of Java type mapping should I use to represent a timestamp column type in a database? Today, we would say, okay, I think Java, the Java time package would be great because it has a local date time type, and that's what we would use. But if we rewind the clock 2 decades back, Java time didn't exist. And so if you go to a JDBC result set and you ask it to map you a timestamp type, it gives you this object type called a java.sql timestamp, which is okay, and it gets the job done, but the local date time type is much nicer and it's more commonly used to represent that kind of information. So that's the type that R2DBC maps to, is a local date time. And that's another kind of adaptation we'll make at the Oracle R2DBC layer, is making sure we're using, there's actually a standard set of types defined by the R2DBC spec. So we make sure we map to those types. So on the screen, I just have kind of the mappings where R2DBC makes these kind of adaptations to implement a connection factory with R2DBC and create a connection. We use the reactive extensions, connection builder, build connection publisher, Oracle, and then statement execute. Same thing. We use execute async Oracle to implement a result where we want to map a sequence of rows to whatever type your function outputs. That kind of maps directly onto our reactive extensions publisher Oracle method of the Oracle result set. And then the connection APIs, commit, rollback, and close. Pretty self-explanatory, goes straight to the reactive extensions. Those are implemented almost like a direct mapping. You can look at the code on GitHub. Blob, if you want to read your blob, you call stream in R2DBC. We implement that using the publisher Oracle method of the reactive extensions, and then we do a similar thing for clob. Okay, so that was basically, if you want to make, if you want to take your JDBC driver and make it reactive, that's how you can do it. But I imagine most of us aren't implementing JDBC drivers and R2DBC drivers, and we want to use them though. And we might not necessarily know too much about reactive programming, or we might not know the R2DBC SPI so well. So the next part of the presentation, I'm going to run through some code examples, and let's just go to the first one. So we're going to see JDBC code on the left and then R2DBC code on the right. And both methods here are accomplishing the same database interaction. And the only difference is on the left, we're going to see how you do that with JDBC and the synchronous APIs. And then on the right, we're going to see how you do the same thing with R2DBC and using asynchronous and reactive programming. So the first example is we're just configuring our connection to the database. And in JDBC on the left, you call all your setter methods on a data source object, your host, your port, service name for Oracle, or database name for other databases, user password. R2DBC, very similar. We're going to use something called a connection factory options object. And we have a nice kind of fluent builder interface to do that. So we can just call the option builder method and provide the exact same information. And that gives us a connection factory, which is kind of R2DBC's equivalent to a data source. It lets us create connections. Okay, so now we can see how to do a query execution where we're actually going to get some row data back. So on the left, with JDBC, we create a statement, we execute it to get a result set, and then we kind of iterate over that result set. Or in this case, I'm just expecting one row. So I just say if there is a next row, I'll map that. The first column value I will map to a string. That's what I'm doing with get string at index 1. And then I say if there is no row, my query return no rows, I'll throw a no such element exception. So on the right side, we see how to do the same thing with R2DBC. Just like JDBC, we create a statement and we call execute. Now with JDBC, when you call execute, it just returns the result because it blocks for the database call. With R2DBC, when you call execute, it's going to return a publisher. And the publisher is going to emit a result type object. So with R2DBC, we say, I want to flat map that result object into another publisher. And the publisher is going to emit mapped row values. So we say flat map my result and return the publisher from invoking result map, where I'm specifying a row mapping function. And that function is going to get the first column value and map it to a string by calling row get with index 0 and string class. We can note R2DBC is going to use 0-based indexes for columns. So the first column is 0. And if you're used to JDBC, it uses 1-based indexes where the first column is 1. The other thing we do is to check for the empty case where our query returns no rows. We can use the flex switch if empty operator, which basically says, okay, I'm going to execute this statement. I'm going to try to map the result into a publisher of rows. If that publisher doesn't emit any row, now I want to throw my no such element exception. So we got time. So let's dig into flat map, because if you're not familiar with this, you should be if you're going to go into reactive programming. So what we do with flat map is we say, you can give me a function f that takes a value of type x and maps that x into a sequence of values, which I've called them the y values here on the screen in the bottom right. And so when we say we want a flat map with our result, like in the example above, we're basically just providing a function that says every element in this stream, I'm going to map that into another stream. And then I want to combine all those mapped streams, those y streams, those y valued streams into one big stream. And that's what you get from a flat map. Okay, so now we're seeing a DML kind of statement. We're doing an insert here. And we're seeing bind values. So with JDBC on the left, again, we have those 1-based indexes, and we have these individually typed setter methods like setInt and setString, which in hindsight, it makes the proposed statement API very, very large, because now you have a setter for every kind of type. And then we can see on the right with R2DBC, we're doing the same insert, and we're using, we'll note we're using the same parameter markers. We're using these question marks. You can also do name parameter markers. That's something Oracle R2DBC supports, and actually Oracle JDBC supports it too. But here we're doing index-based binding because we're using question marks. And with R2DBC, if we want to bind a value, we just call bind, and we pass the value in. And we don't have those individually typed setters. So we don't have like bind int or bind string. We just bind. And if your driver supports the input type, it sets the value, and if it doesn't, it will throw an exception at you. The types of an R2DBC driver supports, there's a standard mapping, and you can find that in the R2DBC spec. So values like int and string are specified, and all drivers should support those. Okay, so after we set our bind values, we execute the SQL, the insert. And here we're using flat map again. But unlike the previous example, where I mapped the result object into a stream of row data, now I'm saying I want to map my result to a stream of update counts. And by the way, a stream can have one value and it can have 0 values. So when I say stream, that doesn't necessarily mean this will output multiple update counts. In the example we have here, we would just expect one update count because only one row is going to be inserted. So this is very similar. This is doing an update with JDBC, setting bind values again, and invoking execute update to get an update count. And we see kind of the same thing going on with R2DBC, also executing the update and then getting the update count. Okay, so here's what I think is the more interesting part of this presentation. Because when I first started doing reactive programming, I kind of had to relearn how to do some basic stuff. So basic stuff like on the left side here. With JDBC, I can ask it to execute an update, and then I can do something with that result in an if-else branch. And one of the things I might decide to do based on that result is now go execute another database call. And that's pretty straightforward to figure out with synchronous code, because Java has things like if-else just built into the language, and return values are just built into the language. But if I want to replicate the same thing with R2DBC, I don't really have the same constructs to work with. So I need to start thinking about, how do I work with a stream of values that are arriving asynchronously and apply operations to those values to get the same effect. So on the right side, what I'm doing is exactly what I'm doing on the left, where we're saying, I want to execute this update. And if the update count comes back as 0, this tells me that the row I'm trying to update doesn't actually exist. So let me go and insert it. To do the same thing with R2DBC, what we want to do is basically create, we can almost think about it as a chain of operations, where the first operation in the chain we know will be an update count. And we don't actually know what the next operation will be until that first operation completes, right? Because we need to know how many rows are being updated by that update call before we decide, should I go execute an insert now, or can I just return the result? So we use a flat map operator, again, to basically say, given a stream of update counts, I'm going to map that into a different stream of update counts if the first value is 0. If it is 0, then we will map to the result of inserting the row. If it's not 0, then we're happy and we'll say, okay, that's the flux just call. We'll just return the update count we have because we've completed our mission, we've updated our row, and that's all we want to do. We can note here, if 2 database sessions, there is a flaw in this code. So if 2 database sessions both ran the same code at the same time, we can think about, they might both see an update count of 0, and then they might both go to do this insert. And if they're inserting a row with a primary key, Now the database is going to have these two inserts coming at it, both trying to insert the same row. And one of those inserts is going to have to fail for violating the primary key constraint. So that's a flaw in this code, and we're going to come back to that later. So here's another example where in some ways, it's similar to the last example we just looked at, where we want to do an insert, or we'll think more just, we want to do a database call, and then based on the result of that call, we may want to do a second call to follow up. But we don't know if we want to do the second call until the first call completes. So on the left, we see with JDBC, we'll run that insert first this time. And if we see a SQL exception with an error code indicating that the row already exists, that's going to be if we violate the unique constraint of a column. If we try to insert two rows having the same primary key value, we'll get this error code. So we'll say, oh, okay, if the row already exists, then let me just go update the value. So in our catch block, we say, if it has this unique constraint error code, then return the result of updating it. And if it doesn't have that error code, then we don't know what it is, and we just throw the exception because we don't know how to recover from that. So with R2DBC, to accomplish the same behavior, we can use an on-error resume operator from the flex type. And we apply this, in some ways it is similar to the flat mapping function, except instead of working with values as input, it works with an error as input. So it says, if you give me an error as input, I'll look at the error code. And if I've violated the primary key constraint, then I'm going to map that error into a stream of the update count from executing an update with the database. So one thing we can note about this code is another flaw. We can imagine if we get that unique constraint violation and we go to do this update, it might be the case that another database session came in and deleted the row, right? Because we tried to insert, we see the row already exists. That row could be deleted before we go to update it. And in that case, this code doesn't really do what we want it to do. It won't actually update the value in the database. Okay, so this will be the last example. And this example is basically trying to address these flaws of the previous two. So let's walk through it on the JDBC side on the left. It basically says, let me do that try update call. And we can remember the failure here was if two sessions ran concurrently, only one of their inserts will succeed. So it says, let me invoke try update, and we'll first do our update. And if the update results in a row count of 0, then we'll do an insert. And then we say, now if two sessions are both running this at the same time, we can expect a unique constraint violation. So now let me catch that. And I'll check the error code. In this case, it's just a not equals condition, right? So it says, if it's not unique constraint, then I'm not expecting that, and I'm going to throw the exception, and we'll exit this loop, this do while loop that we're inside of. But if it is a unique constraint violation, then let's continue to the next iteration of the loop. Let's just retry this. Because now if we see unique constraint violation, we know the row already exists. So let's try that update again. And if the update fails again, we'll try the insert again. And if the insert fails again, we'll go back around in the loop again and again and again until one of them eventually succeeds. So now we can look at the right side. How do you do this? If that wasn't complicated enough, how do you do this with reactive programming? How do you create a loop of essentially publishers that are going to return the result of a database call, and then based on the result of that call, we'll go around and possibly for another iteration of our loop. For me, this was the hardest problem to solve when I first started reactive programming. So the way we do this is sort of a form of recursion. Typically, we think of recursion as something like searching a tree and a synchronous method calling down into itself and recursing. This is an asynchronous form of that. So what's happening here on the right side is I'm doing my asynchronous update with a try update method. And if the update count is 0, then the publisher returns with the result of trying the insert. And now we say we're going to use an on-error resume operator, which just like on the left side with JDBC, where we were able to catch the SQL exception, this is the equivalent for a reactive streams publisher, is to say, if we get that error result, let's map that into another publisher. Let's do a sort of flat map operation. So we'll look at the error code. And here again, if it's not unique constraint, we're not expecting that. And so we say, okay, this publisher completes with an error because we don't know how to handle this one. But if it is that unique constraint violation, we're basically invoking that top level method, right? We're in a method called loop R2DBC, which returns a publisher of integer. And now inside of the on-error resume function, we say, I might map the result of myself to another attempt of myself. I'm invoking loop R2DBC again. And so in this way, it's kind of a recursive solution to the problem where we're creating this chain of database operations, and we need to know the result of the first operation before we know the next operation. And we can kind of perpetuate that with flat mapping to replicate what we do in a loop, which is kind of doing the same thing. It's just trying a database operation, looking at the result, and then deciding if it should go around for another iteration and retry those operations again. So that's the final example. Yeah, and so hopefully the takeaway here can be that if you know synchronous programming, reactive might look a little scary, and it might not be obvious how to accomplish the same things you can do with synchronous using reactive. But what I've been trying to demonstrate is that there are ways to do so. And if you get familiar with libraries like Reactor and you get familiar with these kind of techniques, you will get to a point where writing reactive and asynchronous code is not going to feel any more difficult or challenging than it would to write synchronous code. So yeah, now we're back at the summary. Not sure what to say here. Basically, we've gone through all the layers from the standard JDBC to the reactive extensions. And we've seen how we've built R2DBC on top of the reactive extensions. And we even see how programmers outside of JDBC who use JDBC or use R2DBC can now write reactive code and accomplish the same tasks and the same work that they can accomplish using synchronous. Okay, that's the presentation.
So we'll see everybody on the Q&A channel.
Yeah, that should be starting pretty soon.
That's right. So we are moving to this channel. I'm gonna leave Zoom now and go to the other channel.
Okay, thanks everyone. We'll see you at Q&A.
Cool. Thank you, Kuassi and Michael, for that amazing presentation and very informative deep dive on the Oracle R2DBC driver. Next up, we have Mark Thomas, who will be talking to us about debugging complex issues in web applications. So stay tuned.